Hi, everyone. My name is Jake Katz. I work at Cisco. I'm Vice President of Product Management for AI ML Solutions, most notably HyperFabric for AI, which I will spend just a minute sharing with you today. But I appreciate being able to kick this off. I would like to start with just level setting the state of the market. A lot of people talk about AI and how they've been working in AI for decades or much longer than what I would call the most recent innovations in AI that really started just a few years ago with the launch of ChatGPT. And the people who embraced it wholeheartedly day one were really the hyperscalers who are driving large language models. And yet they still make the bulk of the news for everyone today with the really large GPU clusters and every iteration of LLM. But what we've also seen is some tech leaders who jumped in. I would call them maybe GPU as a service leader, as well as some financial industries that jumped right into this market as well, that started building out clusters for their own language models. And that started happening about a year ago, and it continues to happen now. But we've really yet to get to what I would call the mass democratization of AI, the longer tail of enterprise that will adopt AI over the coming years and decades. What I'm going to start with is a little bit of best learnings and things that have been going on in the hyperscalers, mostly because they set the playing field for the rest of us and how we will adopt AI and also best practices. So in the early days of AI, everything was really based around InfiniBand. And it continues to be one of the main networking technologies within AI promoted by NVIDIA. What we've seen over the course of this year, however, is hyperscalers moving towards Ethernet with a technology called RDMA over converged Ethernet. And some hyperscalers have already announced large clusters built over RoCE. I think this is just the first step. This, as well as work in Ultra Ethernet Consortium, will drive us towards better lossless characteristics, more deterministic characteristics in Ethernet that will be adopted within AI. One of the other things we've seen is the growing bandwidth demands on the network that AI has driven. And so today in the hyperscalers, you see 400 gig data centers, but in the next 12 months, I think what you'll see is those moving towards 800 gig. This is much different from the rate of innovation or the rate of speed that people are using in their front-end data centers, where it's typically around 200 gig growing to 400 gig. So definitely AI is pushing network capacity. And it's pushing how big people build. So in hyperscalers, you're seeing them build bigger GPU clusters, which is causing bigger regions and having them look at what they need to do across regions to make this efficient. One of the other big things about AI is it's very power hungry. And so what you see now are a lot of people who have adopted air-cooled solutions starting to look at liquid-cooled solutions. The current generation of Hopper series H100, H200 come in both variants, and you see people adopting both variants. But there will come a time, perhaps beyond B200, Blackwell 200, where you won't have the availability to do both. You might be stuck in going to just pure liquid-cooled platforms. And what that really means is if you're on this AI train and part of this AI journey in trying to keep up with the rate of innovation that NVIDIA is pushing into the market, it means you need to be prepared for it over the longer term. This means having the power thermal capabilities built into your data centers for the long haul and being able to ensure that if you need to move to liquid cooling, you have that capability. These are pretty big impacts across the board from how people build these large clusters, or even if you're deploying smaller ones in more reasonable sized data centers, your ability to power cool these devices is a challenge perhaps in a legacy data center that might only support something like 8 to 10 kilowatts a rack. That might be the equivalent of maybe a single H200 HGX server with 8 GPUs. So it's definitely putting pressure on the entire piece of infrastructure, not just networking, how customers build out and prepare for AI, not just for their first step, but for all of their AI journey. I think the other pieces that people need to be aware of is that GPUs are still hard to get. and they will probably continue to be hard to get for a while. And then the data that you want to use for any of these AI workloads, and that proximity needs to be factored in. So we've always had these issues with data lakes being in different regions of the country or in different regions of the world, and now that becomes much more stressed because you really need data locality for your workloads with these very expensive, powerful GPUs. So what does that mean? In terms of customers' needs in their journey for AI, we have a continuum of customer needs from hyperscalers on one end all the way to the Fortune 5000 enterprise users. And how they deploy this does matter. At the hyperscaler level, they're really building everything, I would say, best of breed and a la carte, where they are going to pick things like systems, perhaps white box systems, silicon, and maybe even perhaps pieces of software, either community driven or their own driven. So customized software for their specialized solutions. And then as we get to those tech innovators and early adopters, we're somewhere in the middle where they don't really have the resources or desire to build their own white box systems or just to look at silicon. So they want something that's built for them in terms of systems, perhaps even software, perhaps some customizations. They might dabble into things like their own management plane, or maybe sometimes their own OS, but it's not quite the same level that the hyperscalers are doing today. And then as we move towards Fortune 100, eventually into Fortune 5000, you're really talking about more full stack solutions where the customer really wants to focus on the end goals and the AI workload outputs more than what is contributing to them underneath of the infrastructure. So what does this mean in terms of Cisco? Obviously, what it means is one size really doesn't fit all. If you're in one of these categories, you might look at it that way, but across the continuum, one size doesn't really work. You need to be able to offer systems. For here, I'll take an example of like the Cisco 8K. You could use your own OS on it, perhaps. You could run Sonic on it. From Cisco, you can take Silicon One and build your own boxes. Or for the early adopters, those tech innovators, Fortune 100, you can just buy Silicon One already in it. It has its own OS on top of it. You could put a management layer of your own on top of it. Or you could go all the way to a full stack solution, which would be the equivalent of a Cisco HyperFabric solution, which I'll talk with you about in just a few slides. Just a quick graphic on that continuum of products that we offer, starting on the left with the full system view. So this would be Cisco 8K or Cisco 9K chassis devices. Then moving obviously to the right, you can see Cisco Silicon One and our client optics as well. Something I'm not going to spend a lot of time on today here, Cisco Unified Compute, but that is something that we offer, which are UCS compute devices, both for generic compute as well as AI GPU workloads. And then going all the way now to managed solutions, either through an integrated solution with Nexus, like Nexus Dashboard Fabric, or the complete turnkey full stack solution of Cisco Nexus Hyperfabric. And then, of course, to wrap all this up, we do Cisco validated designs to show you that it works and to prove that in an underlayment of security across everything we do. I'm going to pivot now into HyperFabric just for the last couple of slides, and I'm going to try and bring this together because a lot of what we've been talking about here for the past couple of minutes really focuses on now what do you need in the enterprise data center and how can Cisco solve that for you. It really turns to how do you manage something of this complexity in an AI cluster. So it needs something that's more solution focused, that's simpler, something that's based off of Ethernet, a known technology that people know how to manage and deploy, something that gives them a cloud-like experience in case they've been playing with AI in the cloud already to date, and something that they can do very easily. So this really speaks to time to value for a very expensive asset because all of these AI clusters tend to be very expensive.
Hey, Jake, you mentioned early on that the hyperscalers do a lot of their own build and their own specific software stacks and things of that nature. You see Cisco 8000 is plugging into that space? I mean, it seems like they would have their own networking gear.
Cisco 8000 actually does participate in that space today. So yes, I do see it there. And some competitive product also plays in that space, usually in higher levels of the overall AI deployment. Higher levels being closer to spine and aggregation layers. Hopefully that answered your question. All right. I would like to spend a moment here on Nexus HyperFabric. Cisco announced HyperFabric in June of this year. It is done in cooperation partnership with NVIDIA. HyperFabric is a cloud-based management system with plug-and-play data center fabrics on-prem. The plug-and-play fabrics are built with specific Cisco devices called Cisco Series 6000 switches. These are 400 gig and 800 gig switches. They are managed through the cloud, through the Nexus HyperFabric cloud. And with this partnership with NVIDIA, we now extend the management control plane paradigm down to UCS servers that have NVIDIA GPUs, NVIDIA BlueField-3 NICs, and we've also announced now partnership with Vast Data as a storage partner in this ecosystem. What this does is gives you now a plug-and-play AI cluster completely managed by Nexus HyperFabric, built on high-performance Ethernet. So it's a full hardware stack, and we will offer as well a full software stack with NVIDIA-based tools, NVIDIA AI for Enterprise, and their NIM blueprints as well. So this is something we look forward to bringing to the market. Unless there are any questions before I close.
Which Cisco server series are you referring to in that diagram?
I don't know that we've put a number to it yet, but these are Cisco UCS devices.
Oh, okay.
Okay, so these are Cisco UCS devices with NVIDIA GPUs and NVIDIA BlueField-3 NICs. And it will be a UCS device for VAST storage running the VAST software storage stack on top of it.
Very clear. Thank you.
The solution is it an NVIDIA hardware certified servers hardware, the CPU, and I mean, well, the GPU is obviously in NVIDIA, and it's a DPU solution. Is that how it works out? Is that what this whole solution is?
No, this is more than that. The solution will allow me at that management layer in the cloud to control everything that touches the network end to end. So GPU to NIC connectivity, NIC to switch connectivity will all be controlled through that cloud-based management system. The hardware itself, the whole solution, hardware and software, will be validated by NVIDIA, our partner, but they are not providing any hardware outside of the GPUs and the NICs.
But it's enterprise, it's NVIDIA enterprise certified server solution.
They will certify the entire solution. They will also certify the UCS server itself.
Right, I got you.
And as customers are buying this architecture, are they buying a reference architecture, a rack scale deployment? What's the actual delivery to market on this?
Yeah, so that's a good question. We have not brought this to market yet. Our plan, though, is to bring this to market as a holistic solution. It's all offered through Cisco and through Cisco's partners, who will install software as needed for customers to run, if they choose to, one of the NVIDIA AI tools.
But that will be on top of separately purchased hardware, is your expectation, probably from that same partner?
It would all go through that same partner. It would all go through Cisco. Yeah, this is not an open system where you can plug in a NVIDIA GPU system from another party that's not UCS into this ecosystem. There are specific pieces of hardware and software that are put on those devices that allow us to authenticate and secure control through our management system.
Is there like on the UCS server, is there a specific service profile that's associated only with this particular architecture?
Yes, it will be very specific to this architecture.
Thank you.
Right.
Are you doing anything specifically to address some of the inherent Ethernet versus InfiniBand problems? I mean, congestion control, lost packets, sequencing and that sort of thing. Is there some special Cisco secret sauce that's going to help make all that work better?
Yeah, absolutely. But I wouldn't say this is constrained to HyperFabric. So 9K devices, as well as the 8K devices, as well as the Cisco 6000 switches in HyperFabric, all implement the latest Rocky features, the latest UEC features. They all the latest congestion notification, PFC, ECN adaptation, etc. So all of that is already built into all of the Cisco devices for networking, and of course, it is part of HyperFabric as well.
And HyperFabric is really the overall solution. It's also the cloud management of
Correct.
of that. And okay.
Are there APIs available for it so you could potentially manage it through some other tool?
Not day one. It isn't meant to be done that way. It is meant to be the tool through which you bring up, manage, and operate your entire AI cluster. So it is meant to be that interface. If you wanted to go in and do something like specific to, say, the VAS storage piece and manipulate something there, you would just go into the VAS management interface and do that.
Okay, because I can't imagine the hyperscalers are necessarily going to want to jump into another management tool to manage their clouds.
Oh, I'm sorry if I misspoke. This is not, HyperFabric is not a solution for the hyperscalers.
Okay.
In my continuum of customers, HyperFabric is meant for the long tail of enterprise customers that want ease of deployment for AI clusters. Absolutely, hyperscalers want best of breed. They do their own management systems. I don't think they're going to be a customer for HyperFabric.
Okay.
You see something like this being deployed in parallel with the other enterprise class solution servers environment that they would have? I mean, this is specific to an AI solution, AI environment, correct?
Absolutely. Absolutely. So the paradigm today, as you're well aware, is AI solutions, AI workloads need special properties. They need a special backend network. So for the most part, they are all greenfield deployments. HyperFabric as an AI cluster would indeed be a greenfield deployment. It is not meant to aggregate everything into that backend network, including your generic compute. I think that's a great vision for further down for the market over time. But today, given the speed disparity and requirements on the network for the backend network to actually leverage that at the front end, it doesn't really make sense at this time.
And when you say is this like a GPU backend network and there's a storage network and then there's a front end?
You're correct. Yep, correct.
All that exists in this environment.
Yes.
Is Cisco referring to this as a reference architecture? Is it something that's got a different naming convention, or how are you treating this so that you've got a combined Cisco, you've got NVIDIA, you've got VAST? How is this being described?
It's not a reference architecture. It is a package solution. It is something we will solve.
Okay.
Absolutely. You will tell us in the ordering tool, you will tell us how many GPUs you want, how much storage you want. Our management tool will actually tell you how many leaf and spine switches and how to configure them, whether you want a leaf spine configuration or a rail optimized configuration based on what kind of workload you're going to do. So this is a package solution.
So there's a configurator. That's what I just heard. There's a configurator to drive towards this solution, this bill of materials. And is there a professional service rendered along with it? Would you go so far as to call this a whole offer?
So the configuration and validation tools are all built into the management system. It will create the BOM, it'll create the cabling, it'll validate it when you put it together. Did you actually build the optimal system that I had configured for you? Then on top of that, yes, I am sure our professional services and our partner professional services will offer additional services, mostly around workload breadth and helping customers through their AI journey.
And one of the things in your early part of the presentation, you called out the unique challenges, the deterministic power, weight, cooling, geometry, this envelope. You've got a finite amount of power, you've got a finite amount of cooling you can accomplish. Is that also part of that return here's what you're going to need. Here's how many BTUs of cooling is going to be required for this. So how much you're going to draw per.
Yeah, absolutely.
Okay.
Yeah, that's a good one. Yeah. Yeah. There's a planning tool along with that because you have to be mindful of how you build this network, how you build this cluster. If you have 8 kilowatts or 10 kilowatts per rack, you can't stick 2 of these. You know, our base UCS server that's coming out, if you're familiar with the NVIDIA reference designs, is an HGX reference design, which is built off 8 GPUs.
Yep.
So that box in and of itself is going to consume 8+ kilowatts. So you can't do multiple of these in a rack. So site planning and that whole piece, we will help the customer with through the tool. Absolutely.